This reaction is carried out with natrium borhydride, which is done because it is a reduction reaction and natrium borhydride is a reducing agent. It is not the strongest and has been chosen for that reason, as we do not want to reduce the ester up here or the carboxylic acid down here. Yeah. The way it does this is, first of all, it dissolves into a natrium cation and a borhydride anion, where one of the hydrogens attacks the alpha carbon of the ketone, as it has a partial positive charge, which then breaks the double bond of the ketone. And this oxygen then latches on to the borhydride with its extra charge, and this forms this here, where the R is the remainder of our reactant. This it will do. One natrium borhydride can react with 4 of these, shown here, after which you will add water, and water will go in to each of the O's, so we form the alcohol, and the bor and natrium will bond to each other with their charge, so we get this product. Another way to reduce is with lithium aluminium hydride, which is a strong reducing. If we do it with this, we will not only reduce the ketone, but we will also reduce the ester and the carboxylic acid. This is because the LAH is much stronger than the borhydride, which is why we chose the borhydride before. This is done by the similar principle. For the ketone, it'll go in here and attack, as spoken before, and it's also how it starts up here. But here we have a leaving group. For the ester, this is a deprotonated methanol, which will latch on to our reducing agent, and down here we will simply have an alcohol group as leaving group, which will latch on, and it'll leave behind here and an aldehyde, which will react in the same way as the ketone and reduce to an alcohol. So here we have 5 reductions in total, 2 for the ester, 2 for the carboxylic acid, and 1 for the ketone. Furthermore, the LAH, if any leftovers are there, when you add water to hydrate, there is a strong reaction between the water and the reducing agent. So it's important to have it all reacted before you add the water, and you will get this product. If you do not wish to react the ketone, you could add a diol, 2 alcohol group molecule, which will form a ketal with the ketone, protecting it, and you could carry through the same reaction, except this out here would now be a ketone instead, after you remove the protection group again.